In this video, we will have a quick review of trigonometry. So let's start with a right triangle. Okay, and this degree is 90 degrees. And suppose we have this angle here being theta, then the value sin theta would be the ratio of the opposite to the hypotenuse, and cosine theta would be the side over or adjacent, adjacent over hypotenuse. Okay? So these are the basic ones, and if you wanna get a little fancy, then we can talk about tangent theta. Tangent theta gives you the value, the opposite over the adjacent. Right. So these are some basic definition of these trig functions. So suppose I'm working with a spatial case. I know the hypotenuse is equal to 1. So still a right triangle, but this time I know the length of the hypotenuse is equal to 1. So in this case, the formulas become a little simple. So in this case, sine of theta would be the opposite over 1, which is just the length of the opposite, and cosine theta would be the adjacent over 1, which would be just the adjacent. Okay, so this is a spatial case if you know the hypotenuse has length 1. Okay, so now let's look at a spatial case. So now if I'm on a two-dimensional plane, so I have x coordinate, y coordinate, and now on this plane, let me make a circle. Okay, so let me make this is a circle of radius 1, centered at the origin. All right, so now if I put any point on the circle, so then by the definition, I know that this distance from the point to the origin is equal to 1. Okay, and from here I'm gonna construct a right triangle like this. Okay, so now this angle is theta. All right, so since we're on a coordinate chart, so any point can be expressed by its xy coordinate. All right, and so by definition of coordinate, then you know that this distance is gives you the x component, and this number gives you the y component, right? So this is from coordinate. So a point can be expressed by its coordinates x and y, and x happens to be, you can see here in this right triangle that I just created, x happens to be the adjacent for this right triangle, and y would happen to be the opposite. I don't mean object, opposite. Okay, So now if we use this idea together, then we'll know that, oh, for this triangle, if we focus on the triangle, we already know the hypotenuse is length 1 because it's from a circle of radius 1. And this angle, let's say it's theta, then we would know that the opposite, which is, this part, which is sine theta, right? Based on what we just discussed, okay? Because sine theta is equal to the length of the opposite divided by the hypotenuse. Okay, so we have the length of the opposite now equals sine theta. Okay, and similarly, the adjacent which is equal to adjacent over 1 is equal to cosine theta. Right, so now I have this length here is equal to the value cosine theta. So now if I put everything together, I realize that, oh, the x coordinate is length of the adjacent is equal to cosine theta for a point on the unit circle, and the y coordinate is equal to the opposite, which is equal to sine theta. Okay, so in summary, on a unit circle means the radius equal to 1. On a unit circle, and I want it to be centered at the origin, we have xy equals cosine theta sine theta. Okay, knowing the angle theta will be able to tell you the coordinates on the unit circle of the point on the unit circle. Okay, and again, if we just look at the triangle, now we have the hypotenuse is equal to 1, the opposite is equal to sine theta, the adjacent is equal to cosine theta. Now by the Pythagorean theorem, we would have sine squared plus cosine squared is equal to 1. Okay, so this would be another formula that you should know. Okay, but I put it under the trigonometry part. Okay, so we started with the definition of sine theta cosine theta from a right triangle, and we look at the special case when the hypotenuse is equal to 1. Then the formulas becomes a little simpler. The length of, the side length of opposite is equal to sine theta, side length of the adjacent is equal to cosine theta. Now if we put together with a coordinate chart on R2 and make a unit circle centered at the origin, we now realize that, oh, then any point on this unit circle, its coordinates can be expressed by cosine theta, sine theta, and cosine theta gives you the x coordinate, sine theta gives you the y coordinate. Together with the Pythagorean theorem, we also know a very useful trig identity, that is sine squared plus cosine squared equal to 1. All right. So whenever you see sine squared plus cosine squared, as long as the input is the same, then you can always simplify this to 1. All right. So we'll stop here.